Hello, this is Bob Golding, a senior escalation engineer at the Microsoft facility in Charlotte, North Carolina. Today, want to give a tutorial on persistent reservations and go over a little bit in how they pertain to the cluster. So I'll talk about the commands and how cluster touch upon a bit and how cluster arbitrates for reservations. So what are persistent reservations? In the beginning, cluster used release and reserve and trespass to reserve a drive. It only worked for single initiator systems. Persistent reservations are key-based, so more than one initiator can use a key to reserve a drive since it's key-based. Each host and cluster has its own key, and the key is registered with each LUN. Some of the basics of persistent reservations. The initiator registers a reservation key with a target. The initiator then reserves the target using its reservation key, either for exclusive access, where no one else can read or write to the device, or write exclusive, nobody can write to the device. Cluster uses write exclusive, by the way. The initiator uses a target and force a reservation. So, for example, if I register a key and I'm initiator by initiator ID reserves it, the target code inside the array will use the initiator ID and match it up with a key. So that's how it knows. And so multiple initiator IDs can use the same key, and that's how it works with multipathing. Initiator releases the target using its key, so all the commands require the key that was used at registration. The initiator can unregister his key, and it also releases a reservation. Okay, so you don't have to release the reservation if you unregister your key. So what are the commands that are used with persistent reservations? There are two basic types. It's PROUT and PRIN, where we send a command to the target LUN and want to reserve. Preempt, which we'll get into, or release, register, some of the examples, and PRN. And PRN is when we want to get information from the from the LUN, and like to read the keys or read all the registration keys, for example. And there's a service action offset, because PROUT and PRN are just generics, and the service action offset specifies what type of action the LUN should take when receiving the command. Some of the service action definition is read keys, read reservations, and these are the numbers that are associated with the SCSI spec. There's preempt, and that's so you could if host A owns a reservation and host B wants to acquire a reservation, it'll use a preempt. Is register. Reservation action register ignore existing. That's what cluster uses to register its keys. And the commands that cluster uses are read keys, read reservations, register ignore existing, preempt, and reserve. Those are the major ones that cluster uses. Now, to register ignore existing is how reservations start off. Each client must first register a unique key for a target disk. Then he uses that key when monitoring his PGR, persistent group reservations, on the disk. So before to register a key, we use the register command. Register and register ignore existing are very similar. So register, if there's already a key registered, it'll fail. Register ignore existing ignores existing keys if you already registered a key. Now in multipath, if you have 4 paths going to the target, the register has to be successful down all paths. And even though later when you reserve, it only has to be successful down one path because since it's associated with the key has already been registered, the registration has to be successful down all paths. So the array or the LUN knows that each initiator has registered that specific key. Otherwise, the reservations won't work properly. Read keys reads all the registered keys from a specified target or LUN. So you could if you could for example, if you wanted to see if your key is registered, you can just do this read keys command and you can see if your key is registered or not. And this is an example. It just gives you a list of keys. Okay, and read keys is alive on cluster. Reserve is where the drive is reserved, and if you want to reserve the disk, and what you use the reserve command, and you use your reservation key that you registered, and now the drive is reserved. There are different types of reserved. You could reserve the LUN, exclusive. We'll get into those just a minute. There's a list of types of reserved. Since it's very flexible. The reservation types are write exclusive, exclusive. So those are the two top ones there. There's only one reservation holder, and no one else can access the drive except the drive that except the host that reserved using that key. Now I highlighted in yellow number type 5, which is write exclusive all registrants. Okay, that's what cluster uses. Cluster uses write exclusive all registrants. So any registered, so if there's one reservation holder, but there is but all hosts that registered a key have write access to the drive. So in the case of cluster and standard disks, there's only one registrant. So, for example, if you were to read read the keys and reservations on a standard cluster disk, you will see that there's only one host that registered a key and has a reserve. If arbitration fails on a disk, okay, part of we'll talk about this a little later in the video, is that first thing we do is we register and we try to get access to the drive. If we can't, we'll unregister the key. There could be multiple hosts trying to arbitrate for the drive on a failover. If you have multiple hosts arbitrating for the drive, only one's going to win, and the one that cannot get the reservation will unregister its key. So there's only one reservation holder. And there's only one key, and the rest of the hosts that do not have their key registered will have read-only access to the drive. The drive can be read, but it can't be written. Here's a map, and it has the different types of reserves. We use write exclusive registrants only as a single reservation holder, but all media access rights commands are restricted to registrants. So if a host registers a key, it has write access to the drive. Now, read reservation is a PRIN command that reads reservations from a target. So you could read the reservation. You could get the key and the type of reservation. This is part of cluster's arbitration algorithm. So what it does, it reads a reservation. It gives the key and the type of reservation for whoever the reservation holder is. Preempt. Preempt is used if another client holds a reservation and goes away, or you want to take the drive away from another reservation holder. So you need two keys: the key of the original persistent reservation holder, and the new key. So you have to know the key of the previous reservation holder. So if A reserve the drive with key A, and you want to preempt, you need key A and your key B to preempt a reservation. This is cluster arbitration in a nutshell. When a resource moves to a new node, the node will register. What happens is that the node will register a key for the LUN. Does a read reservation command to get the owning node's key. Then it attempts to reserve. If that works, you've done. If the key exists, it will preempt the reservation and then issue a reserved. If the preempt or reserve fails because another node has grabbed the disk, we'll do it unregistered to the PR key. So on the disk there'll be one. So there'll only be one registration and one reservation holder. If a drive fails over, and it's a multi-node cluster, say 3 nodes, and node 1 fails over, 2 and 3 could both arbitrate for the drive. So the preempt or the preempt or reserve could fail. Okay, because you're both trying to arbitrate, so 2 nodes are trying to arbitrate to drive. So the loser of the arbitration will unregister his key. Now once the drive is reserved, okay, and there's only going to be one key registered, one reservation holder. No other host can read or write to that. Could write to that drive. They can read, but they can't write. Now the exception to this, this is what is CSV. Now, when CSV mounts the drive, or they call it mapping the drive, CSV will, as far as CSV code, will register the key of that node with the drive that's being used by CSV. So, for example, if you have hosts 0, 1, and 2, and 0 owns the drive, he has the reservation key. The other 2 nodes, since it's CSV, will register keys, and they can read and write to the drive as well. That's so direct I/O will work. And when the CSV, if you remove CSV, it'll unregister its key, so you go back to the original configuration. Okay, I have a blog that describes I have a blog that describes a bit about reservations, and I have a failure in the blog, and that failure was taken from a 2-node cluster. So that was a real failure. I gave for example, and that failure looks very similar to an arbitration failure on a 2-node cluster. If node 0 fails and drive moves to node 1, there shouldn't be a problem with reserving the drive because there's only 2 nodes. So if host 0 goes down and you move to host 1, you should be able to preempt the reservation, reserve without a problem. If you can't, there's a problem with the reservations. Okay, there's something wrong in the CN or something that's causing that to happen. Okay, so when we let's go back to the arbitration. Okay, we do a read reservation to get the owning node's key so we can preempt. And again, if you have 2 nodes doing this, one node may fail. The preempt may fail. If the other node preempts and gets the reservation, you've got 2 nodes preempting. Only one's gonna work. Okay, so we do the preempt and then the reserve. If one of those fails with the reservation error, we unregister the key because that's interpreted as an arbitration failure, which is typical if you have more than one node trying to arbitrate. Okay, and again, this is my blog. AskBob.tech. There are other articles out there that you may find interesting, so give it a try. And I hope you enjoyed the video. Thank you.